Hey friends, it's Jamie. Today I'm going to go through a full hardware build of the DredCine 20. We start off with a Tune RC Poly F405 all-in-one flight controller. Version 1.2 provides a much better placement of the battery pads. So both the positive and negative wires of the XT30 come out the side instead of straddling a standoff. This build features the DJI O4 Air Unit. Take a look at this. It weighs less than 10 grams and provides full 4K recording. We'll be using the Radiomaster RP3 ELRS Receiver, which features diversity antennas and best-in-class receiver sensitivity via the onboard LNA, plus 100 milliwatts telemetry from the PA. Of course, I prefer Gemfan Hurricane 2023 propellers, and a standard build uses GEP RC 2-inch prop guards in translucent white. Which standoffs you use will depend on your video system. For an O4 build, I'll use 30mm M2 knurled aluminum standoffs. The M2 gummies that come with this flight controller don't provide enough clearance for the frame, so I'll use 6.5mm gummies to provide additional clearance for the flight controller XT30 solder joints and the USB connector to fit between the frame and the flight controller. You could use plastic spacers if you chose. These 4 red 3D printed PET-G pieces are simply motor spacers I use during assembly to allow me to build without the motors flapping around. I already have an XT30 connector prepared with 3 inches of high quality 16-gauge silicon insulated wire and a low ESR capacitor, so I don't show this part of the build today. I prefer about 3 inches of wire and a thicker gauge than provided with the flight controller. For a 3S build, I use the RCN Power GTS version 3 1303 8000 kV motors. Now let's get to work. The next thing we do is a mechanical fit test. I install 4 20mm M2 stack mount screws, securing these tightly to the frame with a metal M2 nut. And the size depends on which VTX system you use and how you mount it. I use these taller gummies to help make sure there's clearance between the main frame and the USB connector, which sits on top of the flight controller when the quad is facing up. I've covered up this close-up view since I later rotate the flight controller by 180 degrees. Here you can see me using the red PET-G spacer to mount the motor. This helps protect the motor windings from accidental damage during fit testing. Next, I measure the proper motor wire length for both the front and the back motors. Every ounce of weight we take off helps, so don't be shy getting these cut and stripped to just the right length. For the rear motors, we want around 30mm of wire, measured from the motor belt to the very end of the stripped motor wire. Each wire should be about the same length, since we'll solder these perpendicular to the edge of the flight controller. You'll see this later on in the build. Maybe on your first build, don't cut these too short, but remember, leaving them too long can also make them likely to get caught up in a propeller during a crash. For the front motors, we want around 40 millimeters of motor wire. I do cut these at an angle, with each successive wire a touch longer, since the front motor wires are soldered closer to parallel to the edge of the flight controller. The O4 Air Unit can be mounted to the same stack screws, again using taller gummies to give clearance for the USB-C connector, which we'll need to access to get footage off the onboard memory. I've cut the connector off one end of the O4 wiring harness. Since the harness is so short, I don't bother trying to make it any shorter. Next, I'll trim the receiver wire harness to be just long enough to stack mount, using a PET-G mounting plate. Then I remove the yellow and brown S-bus and ground wires from the O4 wiring harness, since I use ELRS. I've been stripping the end of each wire just by pinching it with a fingernail and pulling off the insulation, then twisting the copper wires together. Time to solder up the electronics. Let's start with the battery wires and a nice hot iron. I like to use a liquid solder flux from ChipQuik. You can get this on Amazon or at Micro Center. I touch a small dot of flux to the pad and the wire and then pre-tin each. The pad gets a nice little bubble of solder, and the wire sucks enough solder in so that the whole exposed end is pre-tinned. The negative pad is like a heatsink, so it takes a little more time to get it hot enough and to get a good solder bubble. I heat the pad with my iron and I feed the solder into the hot pad. This XT30 wire was pre-tinned before I started the build. Before finalizing the solder joint, I'll add a touch more flux and make sure my iron is hot and has a wet tip. The negative battery pad takes a little longer to solder than any other joint, but make sure not to burn your board. When I'm satisfied with the connection, I remove my iron quickly, dragging it away from the board to prevent molten solder splashing onto the flight controller. Repeat with the positive connection, but this time it will go a bit quicker. Slide the iron away from the board when the joint is clean. Don't be afraid to go back and clean up a joint that you're not satisfied with. This usually takes fresh flux and fresh solder on your iron. Notice the quick slide of the iron off of the joint for a clean bubble. The very next thing I do is I test for short on the battery connector. Do this by using the diode setting of your multimeter. Touching the probes together should create an audible beep telling you they're shorted. We test both negative and positive pad for shorts to ground using the USB connector as our ground reference. Watch that again. Notice my red probe was simply anchored on the USB connector. Now let's pre-tin all of the motor pads. We use the same method as before. Add a touch of flux to each pad, add solder to your iron, heat the pad, and push the solder onto the hot pad. Sweep the iron off the pad quickly when done. Pre-tin the motor wires as before, using a touch of flux and holding a wet iron against the wire. For this full video, my soldering isn't sped up. I want you to see my technique and how long and how hot I solder. My iron is almost consistently around 375 degrees Celsius or about 700 degrees Fahrenheit, though I will get it up to 400 degrees Celsius for the battery wires. I will speed up as I add flux, just not when I solder. Also notice I'm using a fume filter to suck the smoke generated by the flux away. To solder the motor wires to the flight controller, I touch the pad with my iron to melt the pre-tinned solder and slide the motor wire into the molten solder pool. Sometimes I might rest the wire right on top of the pad as I'm melting the pre-tinned solder. And again, we quickly slide the iron away from the pad to get a clean joint. Lifting the iron straight up can cause a peak to form, but sometimes it's hard to get a good angle when sliding it away from the board isn't possible, and we can always go back and clean up an ugly solder joint. Hold the iron on the pad just long enough for the molten solder to flow both on the pad and into the wire. I want to see the solder from both the wire and the pad joined together. decided that the exposed wire is too long. It needs to be trimmed to fit the pad just right. We don't want any exposed wire hanging off the pad. Make sure that the end you cut off doesn't end up on the flight controller. It can cause a short and destroy your flight controller. Next, we'll solder the VTX to the pads for serial port 1 and power. If your flight controller has 2 amps available via the onboard 5-volt supply, you can power the O4 directly from the 5-volt pad. On a 3S build, you could also choose to use battery voltage for your positive lead. For a 4S build, you'll need to use a back or onboard voltage regulator, since the O4 Air Unit spec doesn't permit 4S power. UART1 is right here at the front top corner of the flight controller. First, I'll solder the power and ground for the O4 Air Unit to 5-volt and ground pads near the R1T1 pads. Out of habit, I generally use the white wire of a serial connector to go to the TX pad of the flight controller. I remember this since the white has a T in it, and it goes to the flight controller TX pad. It just so happens that this is also exactly how the O4 Air Unit is connected. The white wire on the O4 Air Unit connects to Air Unit RX and Flight Controller TX. On this flight controller, the TX1 pad is at the edge and easy to solder first, since the RX1 wire will go over the top of it. For the receiver, we'll use R2 and T2 pads, remembering to solder the white wire to the T2 pad of the flight controller. On this flight controller, UART2 is also right here up front on the top. It conveniently has power and ground right there for us as well. Technically, the 2 amp spec of the onboard BEC is probably a touch low for powering both the O4 Air Unit and the receiver, since the Air Unit spec is 2 amps. But I think we'll get away with it. White to the flight controller TX2, so green goes to RX2. Since white went to the flight controller TX, white goes to the receiver RX, green goes to receiver TX. Time to check for shorts again. Every ground pad should beep when I'm holding one lead on the battery ground or USB connector, which is also grounded. Everything else should be silent. The number readout on the display might not be 0, meaning there's a measured resistance, but that's okay. I want one ELRS antenna coming out each side of the heat shrink on this receiver, so I'm placing the antenna wires as I want them and then protecting the receiver with heat shrink. When I started this build, I chose the wrong stack mount screws, so I'm replacing them with 20mm screws. I haven't shown this on screen, but after finishing the solder work and before adding heat shrink to the receiver, I cleaned all the flux off the board. It's acidic and can even be conductive. We don't want it to destroy our flight controller. I used 90% isopropyl alcohol and a toothbrush to get the board nice and clean before assembly. Make sure to let the alcohol dry completely before testing. The front of the drone is facing the camera right here, and we assemble it while upside down. And I'm pointing with my left finger to the white arrow on the top of the flight controller. That arrow faces forward and should be on top when we turn the quad right side up. When upside down, the USB connector is at the right rear side between the flight controller and the frame. Next, we simply add the O4 Air Unit to the stack. I've blocked this view out, however, since I later decide that there's a better orientation that lets us access the USB-C port on the O4 without taking off the propellers. I later also decide I want a 1mm nylon spacer between the flight controller and the O4 Air Unit gummies. I then secure the stack with M2 lock nuts. The stack assembly is complete. I could have also used a receiver mounting plate to put the receiver on the stack, but today I'm going to mount it to the bottom frame plate. Don't tighten these down so much that the gummies get squished. We want it tight enough that the flight controller won't rattle around, but loose enough for the gummies to do their job of reducing motor noise. I've now plugged in the O4 wiring harness and will begin adding the standoffs. In hindsight, it might have been easier to install the camera plate to the top frame plate using these vibration dampers before assembling the rest of the frame. But after doing this a few times, it gets easy to install the dampers. I'm installing these with just my fingers. If you get stuck, then use dental floss. I'll show this technique in a moment. The propeller guards mount between the frame arm and the motor, and when oriented correctly, one of the 3 propeller guard supports extends directly in line with the arm of the frame. The motor falls into the pocket to keep the motor wires running under the arm. This is shown really clearly in my O3 INAV build video. With a little practice, you'll get used to installing the propeller guards and motors pretty quickly. The last one I install is where the battery wire and XT30 come out the right rear of the quad. Make sure it sits above the propeller guard. You can see right here where one part of the propeller guard goes straight out of the arm, which creates a pocket for the motor to fit into during assembly. I use ORT Vee antennas on all my CineWhoops. This one has a very short 5cm cable. We'll anchor that to a standoff with 2 zip ties. On this build, I'm also just using a zip tie to anchor the receiver to the base plate. I could have used a 3D printed receiver mount, but I'm trying to save as much weight as possible. I also anchor the receiver antennas with zip ties. Secure the base with M2 screws and the frame assembly is mostly complete. I like one antenna zip tied to the back left arm. Make sure the zip tie goes between the motor wires and the frame so you don't pinch the motor wires. The next antenna I mount to the very front of the quad on a standoff below the propellers, so I have good reception coming back to myself from a long flight. Now we connect the camera plate to the main frame using the vibration dampers. Sometimes I use dental floss to pull the dampers through the camera plate since there's not much room to work with. Feed a loop of the dental floss through the hole, around the damper, and pull the top part of the damper back through the hole. Finish up the motor mounting using a total of 4 screws per motor if you didn't do this earlier. The O4 camera mounting is next. In this video, I've used the DJI provided snap fit frame and a standard DredCine 14mm camera mount kit. This ended up having too much jello, so I've since designed a much better 3D printed TPU mount that holds the camera better and also provides improved crash protection. For both types of mounts, you install metal nuts inside the 3D print and anchor it to the camera plate using M2 screws. If you use a standard mount, you use only 2 of the camera mount screws provided by DJI. The DredCine 20 flies a props out orientation, so install your propellers such that they provide lift when rotating away from the camera. Final zip tie to anchor the antenna wire better. And our DredCine 20D 3S O4 Lite is complete and under 100 grams.